So let me do a quick intro on myself. I'm Paul Speciale. I'm the VP of Products for Scality. I'm responsible for the roadmap. We do have development going on in Europe and in the United States, and I work very closely with Giorgio, who's our CTO and one of the founders, and I believe that he'll be one of the presenters at the upcoming Tech Field Days. So let's dive into kind of the technology side of the discussion. One piece of context I wanted to give to just tie into what Jerome said. So for us, it's been a matter of shaping this roadmap really according to what we hear from the customers. And what do we hear, right? We hear that there are still classical legacy applications that need to talk file. So we've invested quite a bit. In fact, one of the most extensive investments in integrating a virtual file system into an object store. That's something that we've had in the market now for about 3 years. When we talk about S3 and objects, this isn't our first go-around with this protocol. We've actually invested very heavily in object interfaces. I think most of you remember that we've been kind of seeking for this API standard, right? CDMI, OpenStack Swift, there have been proprietary interfaces. This is really for us the second coming of the S3 interface. And why has it grown? It's grown because we're hearing it from customers across the planet, and we're seeing ISV adoption, right? So we've used S3 now as a vehicle really for integration with backup and archive and surveillance and all kinds of applications. So we'll talk about S3 as a new offering in the Scality ring, but going back to 2011, we actually did have a point offering. So really the focus now is much more modernization, rapid, agile development, and you'll see really the focus is on enterprisation, making this fit into the enterprise environment. So that's really the key thing I want to focus the feature set and the architecture discussion on. So what is it? It's the Scality S3 connector for the enterprise. We have adoption of this now happening very rapidly. It's actually been a surprise to us. We've seen it in service providers across the globe, but now we're in financial institutions. We are in healthcare. So we're seeing this really very broadly adopted. These customers are very, very demanding on deployment. So we're going to talk a little bit about how we make this easier to deploy. Software-defined storage, which is what we do, is classically more complex, right? It's not delivered as an appliance. So we're not pre-installing the operating system or the packages for the software. How can we make this very easy and still stay within the spirit of an SDS offering? I'll talk about multi-tenancy. One thing that we've heard resoundingly from our customers is that fitting into their security environment is paramount. So how do we do that? How do we do federation with Active Directory? And I'll talk a little bit about reporting and management. Okay, so one of the big technical cornerstones that we've made a choice to go after is to really start a very uniform, very simple deployment model based on container technology. So we are a Linux product. The traditional model we've had is that we target Linux distributions like CentOS, Red Hat, Ubuntu. There were still a lot of manual configuration, right? We were very dependent on specific packages and doing configuration files. Doing this now as a set of Docker containers simplifies that process. So essentially we have a set of services. These services together provide the functionality of an S3 server. They provide security, they provide metadata. We think metadata is a real core of managing highly scalable storage systems. And those get deployed uniformly on all of the nodes that comprise a cluster, okay? The first thing that we've engineered, and this is a simple line, but it's hard to do, it's full scale out. Okay, and I'll show you an architectural diagram of how we do that. Scale out at all tiers. The server component is actually stateless, so you can do normal HTTP IP load balancing. We can do failover. There isn't anything that we retain in the server itself that we're dependent upon if that process fails. The Vault service, this is a core thrust of what we've put our energies into. This implements the Amazon multi-tenancy model. So this is what they call IAM, or Identity and Access Management. If you've used Amazon S3, you already know this. It's accounts, users, groups. How do you get your keys? You get an access key and a secret key. There's the notion of roles. We've gone one step further and actually integrated that to make it management compatible with the Amazon tools. Okay, so the commands are identical. The command line interface that's provided by Amazon actually can be used to provision the users, the groups, and the roles in our system. Furthermore, that then sets the basis for federation. Right? So you have an Active Directory domain in a typical bank, and now you have this new cloud model of multi-tenancy. How do you map those together? Okay, and I'm going to talk to you about how we do this through federation using SAML 2.0 technology. Finally, the heart of what we do is a scalable metadata service. So we've put really most of our IP, most of the energy. This is really the hard part. How do you make metadata scalable, resilient, consistent, geo-distributed, right? These are hard problems in computer science, and I'll give you an architectural peek at how we do that. All right, so let me make a couple of more notes about multi-tenancy. So the object models that we've dealt with before have been hit or miss on how they support multi-tenancy. Now we're able to bring this IAM model to service providers and to the enterprise and really let them have what the tools that they need at their disposal. So what do they need? They need the ability to manage groups of users. They want very granular access control, right? So IAM not only defines the entities, but it also has policies. Okay, so these policies are extremely granular. I could allow you access to an object or a bucket and deny you the ability to delete. So those kind of granularities. I can create users, add groups, assign users to groups. I have very, very extensive authentication schemes. The latest HMAC schemes from Amazon are called Signature v4 and v2. Very secure. They create a signature based on the headers and the payload content. So this is one of the ways that we're introducing this to enterprises and saying, it's okay, have many applications hosted in the same environment and provide chargeback and security at that level. That is a great start, but customers are coming back and saying, I need encryption. Okay, one of the things that the Amazon API does provide is server-side encryption. That's one of the models we're going to go down. The first incarnation, however, we're implementing is a transparent bucket level encryption. So how do you do this? When you create a bucket, you essentially invoke a header. That bucket now becomes an encrypted bucket. The other key thing we're being told is do not store encryption keys in your data storage. We want this to be a call out to a customer-provided KMS. We're integrating with KMIP, which is a standard API, so we can plug and play a lot of different vendors. We invoke that on put. They generate an encryption key based on a bucket, and then we invoke it on get to retrieve the encryption key. Okay, so two things right off the gate that make this very, very secure. So let me say that I've presented that to service providers, and they go, that's great. I love this vault. It's self-contained. It gives me multi-tenancy. In the enterprise, they will stop the discussion and say, I need federation. I need Active Directory. So how do you make this work? The way it works is through a three-way handshake. Okay, so you have a client making the request for authentication. You have our service, which manages the cloud model of multi-tenancy. And then you need a third piece called an identity provider, okay, an IDP in short parlance. There are many on the market that are SAML 2.0 compliant. The one that we run into all the time, of course, is Microsoft's ADFS. Very, very common. But now I'm seeing third parties, Ping Federate from CA. There's a whole bunch of them. So the only dependency is that it supports the SAML 2.0. It's the IDP that provides the mapping, right? So this is where you go in. I can show you screens from ADFS where you say, this domain maps to this IAM account. This user or group is going to become a role. Okay, so that's the way that Amazon, the semantics of Amazon really want this to work. Okay, so the vault enables the single sign-on. You now do not need to go and create every user that you know about in AD in our vault. We auto-instantiate. We actually assign the user to a role. The role gets temporary credentials. So we can map the user's Active Directory permissions to that, assign keys, and also provide an expiry time. So it's very secure. Okay, and then once that authentication chain takes place, you're happily running against the connector with all of your credentials. Okay, what about utilization reporting and monitoring? So let me say that as a trend, what we're hearing, especially from big service providers and big enterprises, is they want to do this through their own tools. Okay, that's a big theme that we've heard. This is not to say that a self-defined vendor-provided UI is important. It is. However, what we're hearing is a lot of popular tools, including Microsoft Management Console, tools from BMC, are now supporting REST. So they want to publish statistics, they want to see metrics, but they also want to manage through third-party tools. So what we've done is actually built a real-time statistics repository. It's based on Redis. So it actually captures a lot of the stats. We will then publish that over RESTful APIs for monitoring and management. The S3 connector itself, for example, publishes statistics that are not defined in the Amazon S3 API. They actually depend on things like peripheral services like CloudWatch. we have an API that extends S3 that provides capacity, bandwidth, number of operations, really at 4 levels. The whole service per bucket, per user, per account. Okay? And then moreover, this API, which can be published and documented through Swagger, can be used by custom tools and also by ourselves to do custom predefined tool integrations. For example, Grafana, a beautiful tool for graphing. As I present this, I always go into a customer audience and wonder, do they even know about these tools? I've had a hit 3 times out of 3 just in the last week where people said, Grafana, that's great. It's the tool we use already. There are many others, right? Elasticsearch, Kibana, Zabbix, but this is the enablement vehicle for getting that done. All right, so let's talk the tech under the covers. So I mentioned that the heart of this S3 connector is a scale-out engine. It's the thing that manages the metadata. This is really purpose-built. So this is part of the heart of the data metadata layer of our back end. We've done this as a resilient cluster. Okay, so it's designed for high availability. If there are failure events, it is resilient. If one of the members of the cluster fails, we do restarts. We want it to be fast, right? So what does fast mean? Fast means bucket operations. How fast is it to insert an object into a 1,000,000 object bucket? How about listing the contents of a bucket based on a prefix? Those kind of operations need to be very localized. They need to be very interactive. The design of the database is a key value store. That key value store is then replicated across the metadata cluster. We recommend it on SSD for great interactive performance. If there's a total disaster, there's an erasure-coded copy of the metadata in our ring. So there's sort of incredible durability on that. So what's the hard part of this? The hard part of this is a distributed consensus algorithm, right? So you're running this distributed cluster. We've based the protocol on a published algorithm out of Stanford called Raft, kind of the latest Paxos. The idea is that there's a leader in the cluster. It's dynamically elected. If the leader goes away, there's an election algorithm for picking another. This can be distributed across sites, even the leader. Okay, so there are rules about how consistent the data is. By default, we maintain strict consistency. So what does that mean? All the reads and writes go through the leader. If the leader's inaccessible, by default, we want to suspend operations. Okay? There are applications that may be able to deal with eventual consistency, but we think that by default, presenting totally up-to-date data is the right rule. Okay?
What are the latency constraints?
So for geo-distributed, metro area is the best possible solution. That means sub 10 millisecond. We know that our distributed consensus algorithm is absolutely okay up to 5 times that.
Is that erasure coding? Is there file replication?
There is not erasure coding. It's purely replicated
Okay, so
key value stores.
Oh, okay.
Yeah. This is distribution of the key value store metadata only.
It's just the metadata.
Yeah.
Okay.
Okay, so typically we'll run this as an odd number of servers within the ring. 5, 7, 9, those are the typical choose points. The only function of that is how many failures can you sustain, right? So we need a quorum. The quorum's the majority, so 3 out of 5, 4 out of 7, etc. Okay? All of this is automatic in terms of resynchronization. That's part of the algorithm and part of the architecture. There is a deep dive paper that we recently published on this, but I would say that this is where the tens of man-years of research have gone, and we've done Paxos before, so we do have some expertise. All right, so how does this relate to scale out? So there's scale out at 3 levels that we look at in the architecture. The first is the server layer. Okay, so this is the API server. If I need to scale total throughput, I can scale out my S3 servers. Okay, these are, if they're big object payloads, it's typically not metadata intensive. These get served through a single metadata cluster, but again, I'm aggregating the total throughput. The back end, this is our ring, right? The ring, it's all about scaling out storage. Basically, more servers, more storage nodes, I get more capacity. What about this middle tier? So if I'm doing bucket operations, I get a fairly high level of performance. The current measurements we've done on our S3 is that we're already on the order of 10 times faster than Amazon S3, and that's in puts and gets, okay? So I have customers occasionally saying, I need 1 bucket to go faster, or I need more aggregate throughput. The first answer is this is already pretty darn quick. But if you need that, guess what? We can scale out the metadata clusters. Okay, so now the aggregate increases. And to be clear, this is aggregate across buckets, right? Because 1 bucket lives on 1 cluster. There is work beyond this if you want to have one bucket go faster, right? Or relocate the load of one bucket. But this is very powerful, right? People are already getting great boost compared to the traditional technologies they have. All right, so that's it on the connector. So let me transition to the server, and I'm going to be bold. I'm going to actually do a demo, which I know is always a bit risky, but
We like
I
demos.
feel good about
We
it.
love demos.
Okay, so let's do it. All right, so this is a big change for Scality, and Jerome hinted at it. So the audience that we were really hitting was the storage admin, right? The people that were ready, once they've made the selection to put these things into production. What about developers for test and development that were usually going to a public cloud or some other open source? What about small scale deployments, right? We typically focused on people that had line of sight visibility into a petabyte. But I have a single server, it has a couple of 100 terabytes. Why can't I run an S3 server on that? And as my application grows, I want to transition seamlessly to the full boat scale out solution. So that's really what this is all about. It is totally free. I'll show you how to get it, and then we'll actually show it.
What are the limitations on free?
The only limitation is that if you want premium support, we have a subscription.
But there's no limitation on the code. You can do whatever you want. I mean, actually, if you want to embed it in a competitive product, go ahead and do it. The only thing you have to do is name us. You need to mention that it's our code.
And Howard, I suspect what you're also asking is limitation-wise, this is a single Docker container. This is not a scale-out.
Okay.
So the whole intent is let's make it downloadable, simple. We collapse everything into one container. You can pull. We store the data
So it's
in.
limited to what the performance of one container will deliver.
That's right. If you're okay with one server, or for it's running on my Mac, it's cool. If you want to grow it, then it grows into the connector. And this component, by the way, is the server in our S3 connector. So the beauty is it's API compatible, right? It's doing S3 calls on all of the resources. Its error responses and headers and everything are compatible. Okay, so there is instructions on our s3.scality.com website. Let me make one more comment. We are using this as the vehicle to do fast ISV certifications. And this has been great, right? Because one of the gating factors is how do you stand up a whole ring for a quick test? This is a way to do something much quicker, right? You download it. We're storing data just in the local volume, in the Docker volume. We've been able to certify big products like Commvault, Simpana, sync and share products like Cetera in hours, right? So this has been a really great vehicle for that. Okay, so let's take a look at it, right? This is the fun part. So what am I going to show you? I'm going to do a quick live server demo. I think we have enough time to do this. I'm going to use a UI called Kitematic. The images actually live on Docker Hub. Okay, so this is where we're going to pull the images from. I'm going to pull the S3 server down. I'm going to start it, so I have my S3 server running locally, and then I'm going to use a free UI, CyberDuck. There are many other such UIs. You can play with the S3 command line interface, the CLI. You can use Cloudberry Pro. There's lots of choices. I chose to use this one. So let's take a look at how this runs. So I'm going to hope that my screen doesn't stay dark. There we go. All right, so let's start with Kitematic. So this is the Kitematic UI. I have connectivity. I'm going to connect to this, and what I expect to see in short order is the Docker Hub interface. Okay, and there we are. Okay, so this shows you Docker Hub with all of the collection of different components that they give you. Let's search for the Scality repo, and there we are. And we see a lot of different ongoing projects from Scality. The one that we're interested in here, of course, is the S3 server. Well, let's create one live. Okay, I had a previous one running. So this will run a little quicker, right? Because one of the beauties of Docker is that once I've got it cached, I only need the deltas. So I'm only pulling the deltas down. You see it tell you go forth and store data. Good, I'm just about there. By the way, you see Scality KMS selected. That's the key management service. If it doesn't see an external commercial product for KMS, it'll use a file interface. So that's what this one's doing. All right, so this UI does depend on me taking a look at some settings. Okay, so what do I need specifically to connect? I need to know my IP address, my port number, and I need to provide my access keys. So that's going to be the next step of what we need to do. All right, so the server is running, right? We see it started. I have stop, restart. Let's bring up CyberDuck. All right, so here's my interface, and I have a number of servers defined. The problem is I will need to go and figure out exactly what port to put in. And I see 32778. Okay, so let's flip back to that. So let me do a quick edit. And the only thing I'll end up doing is 32778. I've already defined my access key, and we have an extremely secret key called secret key that you're not seeing here. Okay, so that is there. All right, once I've got this saved as a bookmark, let's launch the interface. So this is the rudimentary CyberDuck interface. What can I do? Well, I can now create a folder. What does the folder end up doing? It ends up creating a bucket. Okay, so Tech Field Day, I've got my Tech Field Day bucket. It should be empty. There it is. I've got a few files here. We do a drag and drop and see if things work live. There we go. And we're transferring data. So these are object put operations. If they are larger files, we know how to do multi-part upload for efficiency in the big connector. Here, it's just streaming things at a normal rate as you would get on your laptop. Okay, so what other operations are supported? Well, of course, I can delete files. This does an object delete. I could empty out the bucket, and I could kill my bucket if I wanted to. Okay, so quick demo of the interactive, but the point of this, it's a real server. It's an S3 server. It's doing the S3 operations exactly according to the specification. All right, so hopefully that gave a little bit of a proof point. Let's go back.
So there's a little one-element ring in there to store the data?
It's using Docker volume storage in this case. So the Docker volume is persisting things locally in my file system.
Okay.
Docker volume, right? Over time, can that be extended to other things? It can. Today it's local, it's on my laptop. The back end of the S3 connector is the ring, but we're really just using an abstracted interface to talk to storage. Okay, so with that, I'm going to wrap up. I hope you got the idea that really what we're trying to do here is to provide this seamless transition from test dev to moderate-sized servers to big scale-out solutions. But really, this has been our focus. We're going to put a ton of energy going forward into enterprise deployments and really proliferate this throughout the enterprise.